Hello and welcome to Sean White's Solar and Energy Storage Podcast. This week we're going to talk about AC and DC coupling of PV and energy storage systems. When you connect PV to energy storage, you're going to have to decide if you're going to connect them together via AC or DC electricity. There are benefits to each for different applications. We will talk about the nuances of AC and DC coupling and give you the benefits and drawbacks of each in this podcast. To find out more and to expand your knowledge, go to solarsean.com. We're going to talk about DC coupling and AC coupling. AC and DC coupling are different ways of coupling different types of systems together. Oftentimes, we're talking about coupling together solar, photovoltaic, and energy storage. Are you going to connect them together on the DC side, or are you going to connect them together on the AC side? There's pluses and minuses to each way, and I try to give you all the pluses and minuses and no personal opinion that's going to sway you away from either way. Because whenever somebody has an opinion, there's always somebody with a different opinion. So energy storage is oftentimes incorporated with photovoltaics. And how do they connect these different things together? We're going to talk about the small scale. Then we're going to talk about the big scale, and it's a lot the same. So this is kind of how it started. Back in the day, 20 years ago, if you didn't want to rely solely upon a generator for your electricity, you probably had solar and batteries. And this is how it used to be connected together all the time. People would take PV and charge the batteries with the PV, and then out of those batteries, they would take the energy out with an inverter if they were going to AC loads. But oftentimes those inverters were inefficient, not reliable, and people would even have DC loads. So think of wiring up your house like you wire up a boat or an RV. I used to live on a boat, and we had a 12-volt system and a 120-volt system. And this is the way it still is for a lot of people. So we call this DC coupling, which isn't extinct, by the way, because everything is connected together on the DC side. So we have PV connected to energy storage, connected to an inverter, and it's all connected together on the DC side. So if I wanted to do AC coupling, I could hook up a PV system with an interactive inverter. That's like a grid tie inverter. And that would be considered AC coupling. And speaking of AC coupling, it looks a little bit more complicated. And here what we're doing is we have an inverter hooked up to batteries, and this is called a multimodal inverter. And what multimodal inverter means, it can do different things, such as it can operate in standalone mode, that means without a utility, or it can operate in grid mode where it feeds a utility. This multimodal inverter with this backed up loads, that's a sub panel right there. This multimodal inverter can make a little microgrid, and that little microgrid can sort of trick an interactive inverter, that means a grid tie inverter, into thinking there's a grid there. And this PV system connected to the interactive inverter can actually charge the batteries. It's kind of funny that multimodal inverter is making the voltage and the grid and the frequency from batteries, but then we could be sending the current back from the interactive inverter to charge the batteries once all loads are satisfied. It's a lot more high tech to do it this way typically, and it helps if things are coordinated. If things are not coordinated, one of the ways that this multimodal inverter can control this interactive inverter is what's called frequency regulation. So interactive inverters, anything that's connected to the grid, these interactive inverters do what's called anti-islanding. That means that they cannot become an island of power. That means that they need to see a grid, or at least they need to see frequency and voltage within a certain range. So this multimodal inverter, when the batteries are getting charged up and don't want to take any more charge because it would damage the batteries to overcharge them, and the multimodal inverter needs to stop charging the battery, it can do frequency regulation, which means it shifts the frequency so it's off a little bit, and it'll turn off this interactive inverter. It won't be off enough to hurt any of the loads, but it might switch it off by about 1 hertz. That's 1 out of 60 cycles per second. And that is called frequency regulations. And so these interactive inverters in the United States, they have to anti-island for at least 5 minutes at a time. So once the interactive inverter doesn't see the grid working perfectly, it turns off for 5 minutes. So the multimodal inverter can take any interactive inverter out there, anyone on the market, and turn it off for 5 minutes at a time. There's a more ideal way of doing it, and that would be to have multimodal inverter and interactive inverter communicate better. If they can communicate better, perhaps the interactive inverter can slow down the output. So it doesn't just totally turn off for 5 minutes. That's kind of jolting. It works in an emergency, but it's just not ideal. So anyway, AC coupling. We have the PV and the energy storage connected together on the AC side. So there's PV going to AC, and there is batteries going to AC. And so if we want to charge the battery, what we're going to do is we're going to take DC to AC, and batteries are really always DC. Sometimes you see a company selling what's called an AC battery, and really what that is that's batteries in an inverter connected together in one box. That's what you see Tesla doing with their Powerwall. And that's also what you see Enphase, that's the microinverter company, doing with their energy storage system. They have AC batteries. And once again, batteries are always DC, but if you hook an inverter up to a battery, then you get an energy storage system that puts out AC. There's different benefits for both AC and DC coupling. So as you can see, one of the arguments that people that are selling DC coupled solutions use against the AC coupled people is they say you're going from DC to AC, back to DC, back to AC, and there's a lot of conversion going on there. And one of the arguments for AC coupling is that it's very easy to convert an existing system. Plus, you're using equipment that is mass produced for making AC power. So it's going to be cheaper, more reliable, and the inverters are often more efficient when you mass produce things like that. So once again, we have energy storage, we have an inverter charger, sometimes it's in the same box, we have the utility, then we have the backed up loads, that's things that work when the grid goes down, and we're connecting our PV system to the backed up load subpanel. So for instance, I have a whole bunch of microinverters over my roof right now, and there's no energy storage on this house. If I wanted to get energy storage, I'm not going to go take all the inverters off the roof and throw them in the garbage so I could do some DC coupled solution. What I'm going to do is I'm going to hook the microinverters up to a sub panel and then get energy storage that's AC coupled. There's also different ways of doing things with microgrid interconnection devices. Let's see what Dynapower's opinion is. It looks like Dynapower to me likes DC coupling. They talk about capacity firming, so that's making even energy out on the grid, energy time shifting, that noontime peak sun energy, and then shifting it over to the head of the duck curve. That means bringing it on in the evenings when energy demand is higher. Then there's clipping recapture. And so what clipping recapture is, in the middle of the day, if you just had PV connected to an inverter, there might be times where it could have made more, but you're limited by the size of your inverter. And clipping isn't a terrible thing, but with these DC coupled solutions, you can avoid clipping. Curtailment recapture. So what curtailment means is the utility sometimes has too much energy and they'll turn the system down or turn the system off because the grid can only take so much, so you can put it into your batteries. That's convenient. Low voltage harvesting is sort of like when it's too dark for the inverter to turn on with just PV alone. Those batteries can get that voltage up there so you can have enough to turn it on, which is probably not a lot of energy. You're going to make most of your energy when the sun's up. And now we have ramp rate control. With utilities that they have to deal with their power plants is it takes a while to turn them on. So a nuclear power plant takes forever to get that thing moving. Coal plant takes a long time to ramp that thing up. But with energy storage, bam, it's quick. You can get energy very quick. So if there's an event on the grid, energy storage can really help with that. That's one of the really great things about energy storage is ramp rate control. Now we have one of their competitors, and they want to sell you an AC coupled solution. This is Eaton. They're one of these big multinational, huge companies. Now we can see from Eaton what they are into. AC coupling. They have AC coupling is best for everything, including cost, because most people think that low cost is better. And high efficiency, high reliability, high bankability, high design flexibility. And so I will let you decide. Another thing that was kind of interesting is I was at Energy Storage International listening to a speaker, and they were talking about high voltage and low voltage AC coupling. They were talking about which side of the transformer you would hook up your AC coupled battery. Would you hook it up over at the output of the PV inverter before the PV inverter gets transformed? Or would you hook it up after the transformer when you're over in medium voltage, that's thousands of volts? It's up to you. It's also interesting that there's different trends with AC and DC coupling. So what year it is might be where it's more trendy to do AC versus DC coupling. In the 2017 National Electrical Code, we broke a lot of the energy storage out of 690. 690 is the place where energy storage was mostly developed, and there was a whole lot of battery stuff in there until the 2017 National Electrical Code when they moved it out. So still, it's good to go back to Article 690 to learn some things, because we can see some images here which they don't have in Article 706, energy storage systems, and also there's Article 480, which is called storage batteries. And yeah, I know it's kind of confusing. There's two different competing articles. One's for batteries, one's for energy storage systems. But this class is about energy storage, and Article 480 is not really used too much. And a lot of times energy storage systems are used with PV systems, but even if they're not, even if they're just supporting the grid, we can get good information out of Article 690 about how that works. Thanks for listening to Sean White's Solar and Energy Storage Podcast. If you want to find out more, take some classes, expand your knowledge, go to solarsean.com. Over and out.